In this video, we're going to look at log equations and inequalities. And this video might take a few minutes because there are 6 examples for us to look at. So let's start with the first one. We'll call this one number 1. We have log base 18 of x squared minus 17 equals log base 18 of negative 2x minus 2. So there is a log on both sides with the same base, so we are able to cancel those logs. And then we're going to bring down what's left over. So I'm going to bring down x squared minus 17 equals negative 2x minus 2. And then I can tell that this is a quadratic equation because it has x squared in it. So I need to put everything on one side of the equal sign and keep x squared as a positive. So I'm going to add the 2x to the right side, and I'm going to add the 2 to the negative 17. So that would just give me negative 15. So I get x squared plus 2x minus 15 equals 0. Then I can factor that trinomial. I need to think of what will multiply to give me negative 15 and add to give me 2. So that would be 5 and negative 3. So from those factors, x would equal negative 5 and positive 3. But we need to check our answer because we do have a log equation and we can't take log of a negative. So we need to make sure x squared minus 17 would stay positive if x is negative 5 or 3. So if we plug in negative 5 and we square it and we subtract 17, that would be okay. And in the second part of our equation on the right hand side, if we do negative 2 times negative 5 minus 2, that would give us 10 minus 2, and that would also be positive. So negative 5 checks out. Let's look at 3. So let me erase that first part. The 3, if we plug it in, would be 3 squared minus 17, which is only 9 minus 17, which would be a negative. So 3 does not check out. So x would only equal negative 5 for example 1. Now let's look at example 2. We have 7 log base 12 of x plus 6 equals 14. There's actually 2 ways you could solve this. So let me explain. You could move the 7 to the exponent of x plus 6, and that would be one way to solve it. Or, let me just write it over here. You could actually divide by 7, and you'll get the same thing. So if you thought of it one of those 2 ways, you're on the right track. So if we divide by 7, we'd have log base 12 of x plus 6 equals 2. And then if we rewrite it as an exponent, we would have log base 12 of x plus 6 to the 7th power equals 14. So then I'm just going to finish it this first way, and then I'll do the second way in a minute so you don't get confused, hopefully. So we have log base 12 of x plus 6 to the 7th equals 14. Now we would need to rewrite this in exponential form. So 12 to the 14th power would equal x plus 6 to the 7th power. Then we need to get rid of the 7th power. So let me grab another color. Let's do the 1/7 power, the reciprocal, which will help cancel out the 7. And that will leave us with 12, and then 14 times 1/7 would be 2, equals x plus 6. So then 144 is 12 squared, equals x plus 6. And then when you subtract 6, you end up with x equals 138. So now let's look at it the other way. If we have log base 12 of x plus 6 equals 2 right here, then we could rewrite this one in exponential form and get 12 squared equals x plus 6. 12 squared is 144 equals x plus 6. And then if we subtract 6, we end up with the same answer. So either way you thought about it would have been okay. So then when you plug in the 138, it would be okay because 138 plus 6 would be a positive. What you're taking the log of has to be positive. Okay, let's see if I have enough room over here for example 3. So we'll number it. Number 3 is negative 3 plus natural log of 5p equals negative 2. I'm going to rewrite it. So I would want to first get the natural log of 5p by itself. So I'm going to add the 3. And I get natural log of 5p equals 1. Then I need to rewrite it in exponential form. So I need my little base that's understood to be an e. So e to the first power equals 5p. And you can type that in your calculator. The little e is second natural log. We'll give you that little e. And then you just type in a power of 1. And you end up with 2.718 equals 5p. And then when you divide both sides by 5, you get 0.544 for your p value. Alright, so let's take a look at example 4. I've written over it with example 1, so I'm going to erase to give myself room to write number 4. Alright, so example 4, we have natural log of n squared plus n equals natural log of 81 plus n. So we are allowed to cancel those logs and bring down n squared plus n equals 81 plus n. And then it's a quadratic equation. Then if we put everything on one side, we have n squared. We want to keep that positive. If I subtract n, then they go away completely. So I'm just going to bring down the 81. Then notice n squared equals 81. So if I take the square root so I can solve for n, then I get n would equal plus or minus 9. So then I go back and check my work. Would that work out with the original problem? So n squared plus n, if that was a 9 squared plus 9, that would be okay. And 81 plus 9 would be okay. So 9 definitely works. Let's check on negative 9. So negative 9 squared plus negative 9 would be 81 plus negative 9, which would still be a positive. And then 81 plus negative 9 would still be okay. So these are both okay for n. So n is plus or minus 9. Now let's look at example 5. Let me erase what I've written here. Give myself some space. Let's see. So example 5, we have log base 12 of 5x minus 6 equals log base 12 of 2x plus 9. So I'm going to cancel logs because they're on both sides. So I can cancel them and bring down 5x minus 6 equals 2x plus 9. And then you just have to solve this linear equation. So let's subtract 2x and we end up with 3x minus 6 equals 9. And then we can add 6 to both sides, so we get 3x equals 15. Then divide by 3 and we get x equals 5. So let's check and make sure 5 would make sense. So 5 times 5 minus 6 would be okay. And then 2 times 5 plus 9 would be okay. So 5 definitely works. And then we have one more problem to try. Number 6. Let me number that one. Let's see, grab my pen. Number 6. Negative 10 plus natural log of n minus 4 equals negative 6. So first I need to add the 10 to get the log part by itself. So natural log of n minus 4 will equal 4. Then it's in log form, but there's not log on both sides, so I need to write it in exponential form. So I put the base of e that's understood to be there, and I put e to the 4th power would equal n minus 4. And then I need e to the 4th power plus 4, because if I add 4 to both sides, I would get n by itself. And then when I type that in my calculator, I end up with 58.598 approximately. And again, the little e in your calculator is second and then natural log. And you should see a little e, and then you have to put the exponent of 4 and then hit enter. And then just add the 4 and you should get what I got.